Are we ready? Example 2. Example number 2. Example 2. We can see that in this example, a company is into production of boxes. And we said here in the question says, a cost accountant has derived the following data on the weekly output of standard size boxes from a factory. We have week 1 to week 10. Are we there? Week 1 to week 10. Then we have output in thousands and we have cost in thousands of dollars. Are we together? So we have output. We have what? Output. Let X. Let what? Let X represent output. And then let, we also have cost, isn't it? Let Y represent cost. Are we together? And we also have numbers. 1, 2. This is weeks. Are we together? We have week 1 to 10. Isn't it? 5, 6, 7, 8, 9, 10. Please pay attention. Forget about copying. We'll copy later. Exactly. Okay. So output. What were the output?
20,
20, 2, 4, 23, 18, 14, 10, 8, 13, and 8. Then we have cost.
60,
25, 66,
49,
48, 35, 18, 40,
33.
and 33. So basically these were the tabulated information, isn't it? Yeah, but if you look at the question, the first question A says plot a scatter diagram of the data. Question B says which weekly output, if any, appear to be different from the rest of the data. Then question number C says state the coordinates of a point which must lie on a regression line fitted to the data above. Then we have find the least square regression of total cost on output and plot the line on the graph. E says what is the fixed cost of the factory. Then F says if a this is where my concern is. This is where our concern is, the estimation part. It says if in a given week it is planned to produce 25,000 standard size boxes. Are we together? Use your regression equation to estimate the total cost of producing this quantity. How many quantity are we expected to estimate? 25,000. Remember that all these figures are in thousands. So 0000 are all here. Yes, also in thousands of US dollars. Are we together? Are we following? So we have to create X and Y, isn't it? And then we have to also create X squared, and as well create that's enough. We already have Y. Are we together? So but the requirement according to the regression model is that we must create X and Y and then X squared. So 20 times 16, 20 times 16, give us what? 20 times 60. I want us all to be practical about it so we can quickly finish. 1200. 2 times 25, 50. 4 times 25, 100. 23 times 66. 23.
1518.
1518. 18 times 49. 18 times 49. 882. 14 times 48. 14. 672. 10 times 35. 3,500. 8 times 18.
144.
144. 13 times 40.
520.
520. And 8 times 33.
264.
264.
4.
264. 264. So that is that. We go on x squared. 20 squared. 400. 2 squared. 4 squared. 23 squared.
529.
529. 18 squared. 18 squared.
324.
324. 14 squared.
196.
196. 10 squared.
100.
100. 8 squared.
64.
64. 13 squared. 13 squared.
169.
169. 8 squared.
64.
64. We are done. So we are now left with summation, additions. So let's do it together. Add all this side, add all this side, add all. These values are in our text already. So let's do it quickly so that we can finish. Look at the side of the text. Column X is what? 120. Column Y? 400. Column XY is on your text there. Look at the 5,700 and
5,704.
5,704. Then this, the last one, the next one, 1866. 1866. If you add up all of this, to give us 1,800 of this. Add up all this, will give us this. If you add up all this, will give you this. If you add up all this, will give you this. Make sure you are catching this ball, because those from far should be able to see the ball. Are we together? Now we have defined the variable. If we look at summation x is equals to what? 120. Summation xy is equals to what? Summation y is equals to 400. Summation xy is equals to what? 5704. Summation x squared is equals to 1866. Now the regression equation formula says it is a plus what? Bx, isn't it?
Yes.
So the first thing we are required to look for is b, where b is equals to summation n. N is what? 10 into summation xy. Summation xy, according to the formula, I don't need to write it on the board again. We already have the formula.
Yes.
So summation x
XY.
y is 5704. Are we there?
Yeah.
Minus summation x 120 into summation y 400. Close bracket and simply divide. Are we together? Not double line, single line. Divide by n. N summation what? 10 into summation x squared. Summation x squared is what? 1866 minus summation x. Summation x is 120 squared. Is that not what you have?
Yes.
That's the interpretation of our formula. So b is equals to 10 times this will give us 5,70400. Are we there? Minus 120 times 400.
Is it 0010?
Just 10, okay. 10, yes, 10. I thought it was, I did by 100. 120 times 400. 120 times 400.
48,000.
Huh?
48,000.
48,000. 48,000. All over 10 times this will give us 18660 minus 120 squared.
That's 14,400.
14,400.
400.
14,400. So B is equals to this minus this. 5740 minus 48,000.
9,040.
9,040.
40.
Are we there? This minus this. This times this minus this will give us what?
4260.
4260. Are we together? So B is now will now be equal to this divided by this. 9040 divided by
is 2.1
122. So in two decimal place is 2.12. That's the value of B. Now A is equal to what? A is equal to what? Check your formula so we don't make mistakes. A is equal to summation Y. Summation Y is what? 400 minus what? Minus B.
Summation X.
B is already 2.12. 2.12. Summation X is what?
120
120.
over 10.
All over 10. All over N. So it's equals to 40. You still need 400 minus this times this will give us 220 something thereabout. Yeah. 2.12 times 120.
254.4.
254.40. 254.40 because two decimal place we are operating. Divide by 10. So it's equals to 400 minus that.
145.60.
145.60 all over 10. So A is equals to 145.60 divided by 10. 14.56. So you can see clearly. Can we rub this out?
Yes, sir.
Are we sure?
Yes. We can do it. I'm not worried about it.
You have this table on your textbook. Look at this. Please come and take your camera and cover this properly so that those from far can see. You have. So you can see that from what we have done, the value of X is clearly defined. Please, every day if you use this board, we must have to clean it before we go. If not, it will dry off. So the formula say R is equals to, remember the estimation. We don't know the value of X in this formula, A plus BX.
Yes.
Are we together? The estimation in your question of 25, they say what will be the cost of producing how many metric tons? 25,000, isn't it? Yes. If in a given week it is planned to produce how many thousand? 25,000 standard size boxes. Use your regression equation to estimate the total cost of producing that quantity. So this is where our emphasis is. That's the estimation value. So you have the value of A and you have the value of B, isn't it? The value of A is what? 14.56 and the value of B is what? 2.12. So R is equals to, the estimation value will now be R is equals to 14.56 plus 12. So is it 12? 2.12. 2.12 multiplied by what? 25. It's 25. Remember the metric tons, everything we are dealing with here is it's in thousand. So the fact that we wrote 25,000 does not mean we put it there like that. It's 25. Which will now be this, it is 14.56 plus this times this times this. 2.12 times 25.
It's 53.
Are we there?
53.
53, right?
Yes, sir.
Okay. Totally 53 or 53 points.
No, just 53.
53. So what you now have, add these two values, 14.56 plus 53. That should give us an average of 64.5 point, no?
67.
57.56. 67.56. So an average of, if you multiply this by
25.
no, we've done that. We are looking for the percentage now. You multiply this by 100 to give you the actual percentage of the estimation. But in other words, about 67.56 thousand metric tons will be produced by this estimation. Are we together? So R is equals to that.
Multiply. Okay, alright.